I wanted to spend a little bit of time today running through this first question on the review packet that you guys had for homework. So the scenario is kind of laid out in these first couple sentences, and then from there you have the equation given that models the scenario, and then you've got some extension questions, A through E. It is a challenging question in the sense that we have to kind of understand the scenario and what's really being created. And as we read through it, they're telling us that there is um, the construction of an open top box. So they take a flat sheet of cardboard that measures 14 by 14 inches. It would be equivalent to saying we've got like this sheet of paper right here. Okay, here's a sheet of paper, flat piece of cardboard. And then what they're going to do is they're going to remove an equal size square on each of the corners. So they're going to remove something here and also here. They're going to remove something here and there, and then the other four corners. And on each of the four corners, they're going to remove the same amount. Well, once they remove that certain amount from the four corners, as I tear my sheet of paper up here, whatever that amount is removed, X from each corner, they will then fold it up to create a three-dimensional object, something that can hold some volume, right? So you can see there's like a length, width, and height now. So what's really taking place in this scenario is they're cutting the corners, folding them up. So X is the side length removed. That's what they tell us, and it shows it right here. X is the inches removed. So X's, we have to think about domain. The y value is v of x. V of x is the y coordinate, and v of x models the volume. So what does that mean? As the volume is y's, that is our range. And if we look at this problem, the initial length and width are 14. The height is only created once you fold up the object. So the height is created once you take off a certain amount and then fold that up. So whatever is removed is actually also the height. So look at this formula here. If you guys remember, the volume of a box is length times width times height. And that's what's taking place here. The length and the width are 14 minus 2x. Why is it 2x? Because there is an x here and an x there. So it's being impacted by twice whatever's removed. The height is actually equivalent to that side length removed, or x. So what we have to do is go through this and answer some questions. What does the domain and range represent in context of the problem? Domain are the x's, range are the y's. So the domain we refer to as the side length removed. So that's our x coordinates. That is the side length removed. The y values, or the range, is referred to as the volume in this scenario, and you can see it right here. But then it asks you the question, what is the domain and range of the function above? So it's actually referring to this equation that's here. So what you have to do is go to your calculator. So I already have it typed in here. You would just go into y1, you would type it in, and you can see exactly as I have it here. I would then go to my graph, but here's the issue. That's really tough to see. Okay, whenever you just hit graph, it'll always use your previous window. So what you instead do is you go to window and you adjust it. The x's are side length removed. Well, I could take off 0 from each corner, but then each dimension is 14 inches long or wide. So think about how much you could take off from each corner. You could take off 7 and 7, and that would remove a total of 14. So you really couldn't take off more than 7. Otherwise, you would lose the whole entire side length. But just so we can see the whole entire graph, let's go to like 12 for an X max. So we just want to see a little bit beyond. Now the Y values are the volume. Okay, so what could the volume be? If you've got 14, 14, and maybe at the height of something, let's make the volume, like 2 to 300, 250. Think about the multiplication of three sides and see what you could get for a number. When I graph it, we can see the function. As x passes, the volume rises and then also goes down. Now the question is asking, what is the domain and range of this function? We have to understand there is an arrow here and there is also an arrow here. So basically on the left and the right side of this, it is rising on one side and falling on the other. It's going forever to the right and forever to the left. So when I go back to the problem, the domain is going forever left and forever right. So you would say all real numbers. The range are the y values, going forever down and forever up. You would say all real numbers. What is the greatest amount that can be removed from each side? I kind of just talked about that, but what this is referring to is if the dimensions are 14 by 14, you obviously couldn't take off more than 7. Because if you cut off 7 and 7, you've removed that whole entire side length, and that doesn't make any sense. So what this really could be said is, what is the greatest integer, meaning like whole number amount that can be removed? So I would say 6 is the greatest, 6 inches. Now, if you said a number anything less than 7, just less than 7, that's okay as well. Use your graphing calculator in the equation from question A, so the one that was given. What is the maximum volume? Now remember, volume, that is our y value. So what is the maximum y value on the intervals x's on the interval 0 to 7? So if my interval is 0 to 7, they're saying only look from 0 to 7 right here, and we need to find the maximum. So I'm looking for this right here. Second trace max, number 4. And then I follow the commands. I go to the left of it, go to the right of it, never guess, just hit enter. So bear with me while I do that. Go to the right, up and over. Don't guess, just hit enter. And we get 2.33, 20326. 2.33, 20336. This was the x, this was the y. Using your calculator, what is the maximum volume? Well, what is it looking for? Y coordinate. 203.36 volume cubic inches, or inches cubed. State the dimensions of this box. Well, we know that the volume is based on x, which is the side length removed. Now the volume is x times 14 minus 2x times 14 minus 2x. In the problem above, didn't we just find the x coordinate that gives us this maximum volume? In other words, didn't we just find the x coordinate, the side length removed, that could give us this volume? The answer is yes, we did. So what is the side length removed? If our dimensions are height, length, and width. Length and width are the same. They're both 14, right? So they could get adjusted and be the same number. But the side length removed is the x coordinate. The x coordinate right here is also the height. So 2.33 inches. That's our first answer. The length is 14. But then remember, what this is saying is you're taking off 2.33 from this corner, and you're taking off 2.33 from this corner, so what's left over? So if I take off, if it's originally 14, but then I got to take off twice 2.33. And the same thing with the width. It's originally 14, but I got to take off twice 2.33. So what we're doing is we're just typing this into our calculator, do the multiplication, 14 minus 2 times 2.33, and we get 9.34 inches. So that is the same thing here, 9.34. So we've got the height, we've got the length, we've got the width, okay? So this problem, they gave you the formula, but the most difficult part was interpreting what the formula means, right? And the scenarios given to us, they got to cut the corners to fold up the edges, okay? That's it for this problem. If you have any more questions, please let me know.